Alright, so this is where we left off with on Monday. We went through reducing fractions, and then we went to multiplying fractions, and now what we're going to do is divide fractions. And remember, I told you a couple of things that you need to remember. First of all, the first step in any of these is to factor first. So if you can factor, then absolutely factor. If you can't factor, then you're just going to start doing the processes. For example, on this one, you're going to keep, change, flip because you see that division sign. Anytime you see a division sign, the first thing you want to do is you want to keep, change, and flip. For example, you're going to keep the first one as is, change your division to multiplication, and flip that second fraction. Now, in this particular problem, we have all monomials, so none of these will factor. And that does allow you to just start canceling out. But if we go to this problem, you can see that there are things that we can factor. But I see that division symbol, so the first thing I want to do is keep, change, flip. Now, if you're comfortable with this, you can factor and keep, change, flip all at the same time, if you can keep your math straight. But just for simplistic purposes, I'm going to go ahead and keep the first one as is, change division to multiplication, and then I'm going to flip that second fraction. Now what I'm going to do is I'm going to factor. So the numerator on the left, I see a 3 that I can bring out, and when I do that, I'm going to have n squared plus 4. On the bottom, I can bring a 3 out and an n, so I'm going to have n minus 5. On the right-hand side, this is a trinomial. Leading coefficient's 1, so I'm going to split the ends up. Signs are going to be different. And think, what can I multiply together to get 10, but add together to get 3? And I'm thinking it's going to be negative 5 and a positive 2. And then on the bottom, I have n to the 4th minus 16, and that's going to factor, that's the difference of 2 squares, so it's going to factor into n squared plus 4 and n squared minus 4. So I know that n squared minus 4 is going to factor again, but at this point what I want to do is I want to see if I can cancel out anything. So I know that I can cancel out the 3's, and I know that I can cancel out the n squared plus 4's, and I can also cancel out the n minus 5's. So for the numerator, if I go ahead and put these together, I'm left with just 1 over here. So we have 1 times n plus 2, which is going to be n plus 2. That's all we have left on the top. And on the bottom, don't forget this n, so we have n times n squared minus 4. So this takes us back to 4.1, which is where we're going to reduce, but I do need to refactor that n squared minus 4. So this is going to go into n plus 2 over n times n plus 2 times n minus 2. That's just the factoring of the difference of 2 squares. So now this n plus 2 group will factor out again, or will reduce again. So I'm just left, remember, if things cancel out, it does cancel out to 1. So I'm left with just a 1 on top. And I have n times n minus 2 on the bottom. And that is going to be your answer. Don't distribute the n back through, because then you just have to turn around and factor it back out. So this is in simplified factored form. So just remember again, if you see a division symbol, you've got to do the keep, change, flip. And then when you do the keep, change, flip, after that it takes you back to multiplication. The first step in multiplication is factor where you can. And then after you factor, reduce where you can. And then just keep going until you have it as simplified and reduced as far as possible. Okay, so let's look at this one. I see a division sign, so I know that I'm going to have to keep, change, flip. So for the first one, I'm going to keep it as is. And then I'm going to change division to multiplication. And then I have to flip this second fraction. This is like a whole number, and all whole numbers are understood to be over 1. So that's going to, when I flip it, it's going to turn into 1 over 4n minus 9. So I took care of the division symbol. now I'm at multiplication, and the first thing I need to do is factor. In the numerator, let's see. Is there anything that will come out of 28, 51, and 27? Let's see. Alright, so again, out of the top, I know an n will come out. So that's going to turn into 28n squared minus 51n minus 27. So I am going to have to do the bottoms up, or however it is you factor. Now the bottom, that is a perfect square trinomial. Yeah, so that's going to factor into 7n plus 3 times 7n minus 3. No, plus 3 again. Times 1 over 4n minus 9. Okay, let's go off to the side and work on this ridiculously huge trinomial. So if we multiply 28 times negative 27, seriously, you're going to get what? Okay. And then that. So we'll have n minus 63 and n plus 12, because the signs have to be different. So let's divide a 28 back out. So we'll have n minus, I'm going to reduce here. So that's going to be 9 over 4. And if we reduce this one, that's going to be, I'm thinking 3/7. Yeah. So if we bring up, we'll now have 4n minus 9 times 7n plus 3. Alright, so the top is going to go into n times 4n minus 9 times 7n plus 3 over 7n plus 3 times 7n plus 3 times 1 over 4n minus 9. Okay, so the 4n minus 9s are going to cancel out. 7n plus 3 is going to cancel out. So on the top you're left with 1 times n, which is going to be n. On the bottom you're left with 7n plus 3. Keep in mind those two n's will not cancel out because the n on the bottom is part of a group. And so that is going to be your answer. I will be mindful of those ridiculous trinomials and try not to give you one like that on the test, because that is crazy. 7n plus 3. Because this trinomial here, the sign's plus, so it's going to be the binomial squared, because that middle is going to double instead of cancel out. So they're both going to be 7n plus 3s. Alright, so before we go here, let's make sure. So we've done reducing of fractions, multiplication, and division. Any questions on that? Please, 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 please make sure you do all of your keep, change, flip, and factoring first before you start canceling out. Canceling out should be second or third step, okay? The only time it would be the first step is if you can't factor and you don't have to keep, change, flip. Other than that, you've got to do a lot of stuff first. Okay, so let's talk about adding and subtracting these fractions. And like I said, when it says rational expressions, that's just fractions. Rational would be fractions, and expressions just going to be your algebra, your variables. When you add and subtract fractions, some things that you need to remember is you must have a common denominator to add or subtract fractions. So that is something that we are going to do different. And you need to keep this straight in your brain for when we do the test. When you do, and it never fails, I have 2 or 3 students that do this every semester. Once we go into finding common denominators, it never fails. Even when people multiply and divide, they still want to find a common denominator. We just came through multiplication and division, and we never found a common denominator. When you multiply and divide, you do not need a common denominator. Only when you add and subtract. So make sure you understand that when you add and subtract fractions, you do have to have a common denominator. And then number 2, make sure you remember how to combine like terms, because that's what we're going to do with our numerators, is combine like terms. So the first thing we're going to talk about is how to add and subtract rational expressions with like denominators. So if you already have a common denominator, you don't have to find one. So that's nice. What you're going to do is you're going to combine your numerators, and then you're going to go back to reducing. It's just like 3rd grade math. When you add fractions, you add them together by combining your numerators. In other words, if you have something like 1/3 plus 2/3, that is not going to be 3/6. You leave the top, you combine the top, so you're going to get 3, but you leave the bottom as is. And then from here, you reduce. Okay? So it's just like what we learned how to do in 3rd grade. When you're adding and subtracting fractions, you combine your numerators, leave your common denominator alone, and then reduce. Don't reduce at the beginning. Don't reduce at the beginning. Okay. So, common denominators. Look, you have to understand and you have to be able to see this. So if you need to just take a step back and look, you can. Your denominators for these two fractions are a group of n minus 1. That n minus 1 is one thing. It's one group. It goes together. You cannot separate it. Alright? So your common denominator is n minus 1. So since we already have a common denominator, go ahead and write your combined fraction over your common denominator. Just leave it be. And then combine your numerators. Well, you have n squared minus 1. Those are not like terms. So you just write it as n squared minus 1. They're not like terms. You can't put them together. Now we're going to reduce. This takes us back to 4.1, what we did Monday. So you're going to factor where you can. The numerator is the difference of two squares, so we'll have n plus 1 times n minus 1 over your common denominator of n minus 1, and that is a group. We can cancel out the n minus 1s, and your answer is just going to be n plus 1. Okay? So if you have a common denominator, one more time, if you have a common denominator, you're going to combine your numerators, if possible. Got to have like terms. Write it over your common denominator, factor if possible, and reduce if possible. So let's look at the one on the right. Your common denominator is this 2x plus 1 group. So let's go ahead and combine by writing it over the common denominator. It's not going to change. And you do not have 2a plus 1 squared, or 2a plus 1 times 2a plus 1, because look, in 3rd grade we learned you combine your numerators, but you leave your common denominator alone. We didn't do 3 plus 3, which is 6. We didn't do 3 times 3, which is 9. We left it as 3. Same thing. You're going to leave that common denominator alone. Now up top, we're going to combine by combining like terms, but we don't have any. That would be a 13. Now what we need to do is we need to see if we can factor. So let's take that numerator and see if we can factor this. This would be bottoms up or guess check, whatever it is you prefer. So is there anything we can multiply together to get 30 but add together to get 13? And then let's multiply or divide back out the 6. Reduce. And bring up. So the numerator is going to be 3a plus 5 times 2a plus 1. And the denominator is that group of 2a plus 1. So you can see these are going to cancel out and you're going to get 3a plus 5. So if you have a common denominator, just put your numerator together, combine like terms if there are some. If there's not any, just write it in descending order. Once you get one fraction, factor, reduce, and you get your answer. Okay? So if you already have a common denominator, it's not easy by any means, but it's easier than finding a common denominator. Okay. Basically, from here down is 4.1. We've already done that. It's just putting the things together. The first step, adding and subtracting, that's where it gets a little tricky. Okay, so what if you have an unlike denominator? Well, again, we did this back in 4th and 5th grade, most of us anyway. If you don't have a common denominator, for example, here we have a 6 and a 12. We have a 6 and a 12. Well, these are not like denominators. So what we're going to have to do is we're going to have to figure out what is the least common multiple, or what is the least common denominator between 6 and 12. And before you say anything, I don't want you to embarrass yourself. Understand, your common denominator has to be a minimum of 12. So 6 is not your common denominator because 12 won't go into 6. 6 will go into 12 though. So what is a number that both 6 and 12 will go into? Smaller. 12. You can use 24. It's not the least common denominator, but it is a common denominator, okay? That just means you'll have to reduce later on. But the least common denominator is going to be 12. So let's rewrite each one of these fractions with our common denominator. And remember what we have to do back from 5th grade. My daughter's in 5th grade, and she's learning how to do this now, so that's how I know that. In order to get 6 to go to 12, what do you have to multiply by? 2. So if we multiply the bottom by 2, what do you think you're going to have to multiply the top by? 2. That is the distributive property. That is the distributive property. So we're going to have 8x minus 6. Now, from this denominator, this 12, to this 12, nothing changed. So the top's not going to change either. So you're still going to have your 8x minus 2. So that's the tricky part, finding that common denominator. This problem's pretty basic. Like I said, it's stuff that we learned how to do a long time ago. Now, remember this, okay? Once you find your common denominator, leave it be. Just leave it alone. So what we're going to do is we're going to combine these two fractions into one by putting it over the common denominator. So we're going to make these two fractions into one fraction with that common denominator of 12. The numerator, we have to combine like terms. And there is a word of caution. This minus sign, this huge minus sign, goes to both the 8x and the negative 2. Okay? It's a group. So it's kind of like what we did in chapter 2. That negative sign goes to this whole entire group. So watch this. You have combining like terms. 8x minus 8x. What happens? It goes away. 8x minus 8x goes to 0. So just don't even worry about it. Now, watch this. Negative 6 minus negative 2. Put it in your calculator if you need to. Negative 6 minus a negative 2. What are you going to get? So I have one fraction. All the variables went away. That is rarely going to happen. But in our particular case here, all the variables did go away. So all you're going to do is just simply reduce, and you're going to get negative 1/3. Okay? So if you don't have a common denominator, you're going to have to find a common denominator. Now, this is a basic problem. It gets a lot tougher than this. Okay? So make sure you understand this concept before we move on. Do you have any questions? Basically, to go from your old denominator to your new denominator, you're going to multiply the top and the bottom by what changed. By what changed. Okay? So, let's look at the one on the top. We're going to make two new fractions. This is a subtraction problem, so the minus sign is going to go in between. We're going to make two new fractions with a common denominator. So tell me the least common denominator, if you can, between, let's just look at the numbers, 12 and 15. Find the least common denominator between 12 and 15. In other words, what's the smallest number that both of these will go into? That will go into 60. Remember, your common denominator has to be at least your biggest number, or bigger. So 3 is not going to work. Okay, now, as far as variables, we haven't done this yet, so we did it in 098, but let's look at our variables. Let's look at the A's first. If you have monomials like what we have here, everything has to be used once and only once. Okay? So here we have 1A and here we have 2's. Let's 2 A's. Let's separate that out. This A and this A are already in common. And then you have to throw in another A. So A squared is going to be your common denominator between your A's. Everything has to be used once and only once. So when we use this A, that one goes with it. They already have an A in common, in other words. There's already one A in common. But now we have another A that we need to worry about. So A times A is where that A squared comes into play. Basically, you're just going to use your highest exponent. Okay? Now, let's look at B. Here we have a B, here we don't. But we have to use it, so we're going to have a B for our common denominator. So, everything has to be used once and only once. Now, here's our common denominator. So let's look and see what changed. From this denominator, 12AB, to 60A squared B, what did we multiply by? We multiply by a 5 and an A. Right? 5 times 12 is going to give us the 60. A times A is going to give us the A squared, and we already have a B, so we don't need to worry about that. So we're going to multiply the top and the bottom by 5A. So on top, that's going to give us a 35A. See if you can find the new numerator for the second one. In order to get 15 to go to 60, we have to multiply by 4. The A squares are already taken care of, right? But we still need a B. So we're multiplying by the things that are different. So 4B times 11 is going to be 44B. This and this. How many? You have to multiply 12 by 5 in order to go to 60. 12 times 5 is going to give you 60. And then 15 times 4 is going to give you 60. Okay, so now we have a common denominator. Let's make one fraction over that common denominator. One fraction over the common denominator. To combine the numerators, you're going to combine like terms. Do we have any? No. So we're just going to write descending order 35A minus 44B. Now I'm going to ask you a really good question here. Don't answer out loud. Just think and mull over it for just a second. Once you have one fraction, you're going to factor and reduce. Your numerator. Think inside, not out loud. Your numerator, will it factor? Is there anything that you can factor out? Is there anything in common? The answer is no. That numerator will not factor. Okay, second question. Think inside because I don't want you to embarrass yourself. It won't factor, but is there anything that you can reduce? If you're thinking no, you're correct. Watch this. This A will not reduce with this A. Why? This is a group. The only way that you can cancel a group is if there's another group just like it somewhere else. So that's your answer. It will not reduce. It will not factor. That is going to be your answer. Okay. While you're in your groups, what I want you to do is I want you together see if you can find what the common denominator for this fraction. Talk about it. All right, let's see if we got it right. The common denominator between these two is going to be 24xy. Okay, so how did we get that? Well, the LCM between 12 and 8 is the smallest number that both of those will go into. So 24 is the smallest number that both of those will go into. As far as your variables are concerned, you have to use everything once. So I need an x and I need a y in my common denominator. I need an x and I need a y. Okay, so the first fraction, we've got to find the new numerators. So what do you have to multiply 12x by in order to get 24xy? Very good, top and bottom. So on the top, we're going to get a 10y. See if you can find the new numerator for the one on the right. 10 seconds. Okay, so what do you have to multiply? Look, this is what I'm asking myself. What do I have to multiply 8y by in order to get 24xy? 3x, top and bottom. So you're going to get 27x. Okay, we have our common denominator. So let's put the fraction together over that same common denominator. The numerator, they're not like terms, so you can't put them together. I am going to write them in descending order, though. I am going to write it in descending order. Now you have to ask yourself two questions. Number one, will that numerator factor? Is there anything in common that I can bring out? Because it's a binomial and that's your only option. Or it's a pattern, of course this is not a pattern. Okay, since nothing will factor, then you have to ask yourself, will anything cancel out? The answer is no. And there's one simple reason. What is it? The top is a group. The top is a group. You cannot split things up, so nothing will cancel. If you don't learn anything else today, please learn that. You cannot reduce the x and the y. You cannot cancel out this x with this x because this x belongs to a group. You cannot reduce the 10 and the 24 by 2 because the 10 belongs to a group. You cannot reduce the 27 and the 24 by 3 because the 27 belongs to a group. If it's in a group, you cannot reduce unless there's another group just like it somewhere else. Okay, so we have done denominators that are just numbers. Those are fairly simple. We've done denominators that are monomials. That's fairly simple. Now, hopefully that you got the hang of it. So now let's talk about three fractions. Same process. Same process. What I want you to do is I want you to find the common denominator for all three fractions. In other words, what is the least common denominator between 7, 4, and 14? And don't say it's 14 because 4 won't go in 14. Between 7, 4, and 14. What do you think? I heard it. 28. So that took care of your numbers. Now, how many t's need to be in the common denominator? Just 2. Because watch this. There's already a t in common. There's already a t in common. And then I still need another one. So t squared is what we need. Now, 3 new. What did you multiply the first fraction by? Good job. So we should get 20t. What did you multiply the second fraction by? Just a 7. You already have a t squared. You already have a t squared, so we don't need another t. If we do another t, that's going to be 7t cubed. And we don't need, or 28t cubed, and that's not what we need. So this is just going to be a 21. And the next one's going to be what? Very good. So the top is going to be 2t. Okay, so we have a common denominator. Let's write it over that common denominator. We're going to combine all three into one fraction. So we have 28t squared. For our numerators, we do have common terms this time. What are they? Good. So we're going to have 22, descending order please, 22t plus 21. Now, will anything reduce? Will anything factor or will anything reduce? Because that's what you got to ask yourself at this point. Will anything factor out of the numerator? No. And will anything reduce? No. Don't reduce that 22 and 28. Do not reduce the 22 and the 28. And the t and the t squared will not reduce either because those are groups. This is a group. Okay, so we talked about numbers. That's easy. We talked about monomials in the denominator. And we talked about multiple fractions. Okay? Now let's talk about groups in the denominator. And this is where it gets crazy. Like I said earlier, you cannot pick these apart. These are groups. Now, in order to find the common denominator, you have to use everything once and only once. Okay? So, your common denominator is going to be whatever's not in common already multiplied together. So you have to write down everything that's already in common times everything that's not in common. There's nothing in common. They're two separate groups. So your common denominator is going to be x minus 1 times 2x minus 3. Because think about it. If I had 1/3 times plus 1/2. 1/3 times 1/2. What would the common denominator be? 1/3 times 1/2. What would the common denominator be? Loud. Tell me. 1/3 plus 1/2. What is the common denominator? 6. How'd you get it? You multiplied 2 times 3 together. Same concept. Exact same concept, except we're not going to fold these out. So your common denominator is going to be these two multiplied together, but don't actually multiply them together. Now, what we're going to do is we're going to make new fractions over that common denominator. So let me ask you the same question that we asked up here. You're going to multiply by what's different. What changed from 7t to 28t squared? And you said 4t. That's what's different, right? Look down here for this first fraction. What's different from here to here? What'd you multiply by? The 2x minus 3. So you're going to multiply this whole fraction by 2x minus 3. So when you multiply x minus 1 times 2x minus 3, you get your denominator. When I multiply 5 times 2x minus 3, that's the distributive property. So that new numerator is going to be 10x minus 15. Okay, what's different from our second fraction denominator to our new fraction? X minus 1. So you're going to multiply this whole fraction by what's different, which is x minus 1. So on the bottom, you're going to have 2x minus 3 times x minus 1. We've already got that as our common denominator. On the top, distributive property. 3 times x minus 1 is going to give us 3x minus 3. Now that you have a common denominator, let's make one fraction over that common denominator. One fraction over that common denominator by combining like terms on top. Again, there is a minus sign here, and that makes it tricky. That minus sign goes to the whole entire 3x minus 3, so be careful of that. So what we have is 10x minus 3x, which is going to be 7x. And then we have negative 15 minus a negative 3. Put it in your calculator if you need to. Negative 15 minus a negative 3, which is going to give us what? Negative 12. When you get here, don't stop. Ask yourself 2 questions. Number 1, will this factor? On the numerator, will it factor? No, there's nothing in common. It's a binomial and there's nothing in common. Number 2, will anything reduce? No, because you have 3 groups and none of them are the same. You have 3 groups and none of them are the same, so that's going to be your answer. Okay, let's try these. Actually, I don't want to go here yet.